Hello, I'm Chris Athanas. I'm a KMP developer, and tech support's coming out Tuesday. They said to close that. So today I'm going to be reacting to this video by Eric Comartin at Code Opinion. At this Code Opinion channel. This is one of my favorite developers for talking about backend stuff. Now, he does get a little into the weeds. I'm not a backend developer. I came from the front end, doing Android and web development, and I've done a little bit of backend stuff, enough to know basically with KTOR. Mostly, it's all been KTOR. A little bit Express. Express kind of showed me like, oh yeah, okay, they've abstracted all this stuff away, and KTOR inherited a lot of ideas from Express, so it's. But it's specifically for Kotlin and Kotlin idioms. So if you learn Kotlin on the front end with using KMP, it's just natural to go to KTOR and use it on the back. And I'm going to translate. So he has a lot of examples in a C#. I don't know if it's C#, but he uses C# as his language. Now we're not using C#, but it's pretty syntactically very similar. It's basically like Java. I did a little it's basically like Java. They clone Java. So if you can read a little bit of Java or can, it's very verbose. But with Kotlin, it's all compatible. So, okay, let's see what he has to say.
If you're working in a distributed application, you're bound to run into the issue of wanting data consistency between services. In this video, I'm going to work through an example that explains the design challenge, as well as different solutions on how you can handle communication and data consistency between services. Hey everybody, it's Derek Martin from CodeOpinion.com. This question and the use case and example that I'm actually using came from a question from a member of my channel. If you're interested in joining, get access to a private Discord server where you can communicate with myself and other like-minded developers, check out the links in the description on how to join. This video is brought to you by EventStoreDB, the stream database built from the ground up for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. So here's the example use case that I was asked about. We have a system where there's kind of two boundaries that we're going to talk about. There's a payment boundary service, which is responsible for taking subscriptions from customers. So a customer signs up for a subscription, pays a certain amount of money, they get that subscription. And from there, you can see in the lower hand here, that's where the payment is dealing with a payment gateway, let's say Stripe, for example, and then it has its own database, where as people are signing up for subscriptions, you may kind of lapse your subscription or sign up for a new one, and you essentially have a balance. So the balance.
Okay, so in the case of our applications, this is going to be one monolith, right? This client is going to be your iOS application, your Android application, your web app, your desktop app, and it's going to do it's going to be using HTTP calls to this whole thing here. Even though it has these lines around it, what you were going to build for your MVPs for these initial things is this modular monolith, and this will all be inside one application. The places with the KTOR endpoints will be accepting orders, and then it'll have you can have a database or a table in one database, just a table just for the orders. That's probably the best way to set it up. And then this broker will just be a channel or a flow, and then it'll also be another service to handle the payments. And that this also can be its own separate database or a table in one database. That's also acceptable, but they should not be talking to each other. Like payment should not talk directly to this one, and order should not talk directly to this database. This payment gateway is, of course, should be kind of out here, but whatever. And that's that you want to make sure you're strict about that. That inside of order, like everything in orders is all order based. Everything that's in payments is just payment based. And you do want to keep them separate internally to the app. But so eventually, if you want to scale these up for whatever reason, they would be possible to do that. Okay, so that's what that's about.
Of what you paid for your subscription. You also have another boundary at the top listed here, which are for orders. And this is the idea is that when you sign up for a subscription, you're getting orders delivered to you, say daily, and those orders have a cost. So every time an order is shipped to you, we decrease the balance in the payment service. So this is kind of the context and the use case that we're talking about. So as well for this example, I'm making assumptions. I don't really have deep-seated knowledge about the system or this domain, but I got the overall gist of the question asked. One important note here as well is that like any type of subscription service is that they do allow you to kind of lapse your subscription in case your reoccurring payment fails. Let's say your credit card expires that was on file, or for whatever reason. So what happens is when that occurs, they don't stop you sending that order daily to you. Let's say there's kind of a 2-day grace period where if your subscription lapses and you have no money in your balance, they'll still send you an order for 2 days in.
It's like this is a business use case, business rule for your particular application. It could be, you can set all these rules up all kinds of different ways.
Probably notify you that you have to sign up again. And once you do, then that balance will be decreased by the 2 days that you actually missed. So that's an important factor as I work through this example here. All right, so here's some workflow that we have, is that we have a client that's gonna continue their subscription that's lapsed by, say, a couple days. That means that we have a couple orders that we essentially haven't paid for yet. So our client hits the payment service and continues their subscription by, say,
that's just an HTTP call from your client. Says, one of your customers says, I want to make a payment now. So that's what he's talking about here.
Providing their credit card details. At this point, we hit the payment gateway, whatever that may be. It charges the customer's credit card. Then we update our database with probably likely that transaction, some transaction ID, and update our balance in the database. From there, what we're doing is we're publishing an event to the broker that the subscription has been, say, renewed, and that order service is subscribing, is consuming that event.
And in this broker right here, I'm recommending use Redis. But if you're just trying to get an MVP going up and you don't really care about the consistency or persistence, you just have it be in memory, and then when the time comes, make it into a Redis so it'll always be there. What's it called? Persistent.
From there, what it's doing is that it's looking at its database to understand, okay, what are the orders that haven't been paid yet? So it looks at the database, sees, okay, there's 2 of these orders that haven't been paid yet. So it's then making a synchronous call, blocking call. This could be an HTTP call, gRPC, whatever the case may be, some type of blocking RPC call to the payment service saying, hey, I have these 2 orders that you haven't paid for. So go to your database, reduce the balance on hand that you just added to it because there's these 2 orders that you haven't paid for. Once that call's done, then the ordering service can then update its database saying, okay, yeah, these 2 orders now, we're good, we're complete, they're paid for.
And notice that synchronous call went from this service to this other service, not from the service to the database. Okay, that's super important. You want to make it, if you're doing an inter-service call like this, and you're doing it synchronously or asynchronously, you definitely want to go from one service to the other. You do not want to go directly to the database. It's bad.
For. So the member of my channel that asked this question really had kind of 2 concerns. The first was, as you can see, they're using events, they're using an event-driven architecture, but they were concerned, well, aren't we kind of going against the grain here now that we introduce an RPC call? So that was one of their concerns. The second one is, as I mentioned at the beginning of the video, is about data consistency. And that's because that RPC call that we introduced from orders to payments, when payments decreased the balance in its database for those 2 orders that were outstanding, once that blocking call was completed, orders at that point needed to update its database saying those 2 orders were paid. But what happens if there's a failure? We've updated our payments database with the new balance, but we haven't updated our orders. So we have some lack of consistency here now where we're gonna have orders that don't look like they're completed, that don't look like they're paid for, but we've already decreased the balance. One option is to remove the RPC call and move to messaging, because each message and how we're consuming it can be executed independently, and we can deal with.
Right, so he's just saying, instead of doing a direct call, we're gonna have a thing that another message broker type of thing that's got an inbox and an outbox. Right, so if the order, that's what he's trying to do. He's like, as if it was a secretary there taking the order, and instead of the order, like have the order taker has to take the order directly, you now have a secretary there that'll take the call if the order deliver guy is busy. That's all we're doing.
Failures per kind of message that we're consuming. So, and that's because with messaging, you just have more ways and more resilient ways of dealing with failures. You may want to do an automatic retry, you could do some exponential backoff, and if a message keeps failing, you could just move it to a dead letter queue and deal with it separately. You're not actually losing any of the workflow if there is a failure. You still have that initial request as a message. So that
dead letter queue is just a database that says, hey, I tried doing this thing and eventually it failed and this is the last stop. And hopefully that database is always going to be available. And if that one goes down, well, okay, well,
it looks like is when our client is renewing their subscription, we hit our payment gateway, we charge the customer's credit card, we update our balance and set the transaction, then we still publishing our event saying the subscription was renewed, our ordering service is consuming and subscribing to that event, and at this point, when it's looking at its database for the orders that have not been paid, it then, instead of making the RPC call at this point, it can then send a command to our broker to a queue that our payment service is actually consuming. So now this payment service is going to get that command, that message that the ordering service sent, and it can deal with updating the balance for those 2 particular orders. At this point, there's different variety of ways you can do this. It could be a reply or it could be an event, but let's say it's a reply using a request reply pattern. I'll have a link in the description on how this works with asynchronous workflows. But we're sending a reply back to the ordering service for that specific message saying, yes, I've completed the updating of the balance of these 2 orders. The ordering service can consume that, understand it's these 2 particular order IDs, and now it can update its database. But as I mentioned with messages, if there is a failure when we're processing that reply and there is a failure, we can do a retry. We don't actually lose the message. We may send it to a dead letter queue, etc. There's a bunch of different ways that you can handle failures, but you're not actually going to be losing the message, which is the reply to update your database and change the status of those orders to paid. Now you may be thinking,
right, and that's the whole thing is like that broker has to always be available. So, that's a use case for Redis, honestly.
Thinking and hopefully are thinking, okay, that's great. So we remove the RPC call. We have a little bit more fault tolerance, but we could still have a balance that's not really reflective or consistent with the order statuses. We still have orders that potentially look like they're unpaid if we hadn't processed the reply yet, and our balance reflects something completely different. We still don't have consistency. Maybe eventually consistent, assuming that message actually does get processed. So one solution to this is to use the reservation pattern. I've covered this in other videos, so I'll have a link in the description. But the idea is that you're creating a time-bound lock on some type of resource.
A time-bound lock on some sort of resource. Okay. All he said was like, "Hey, instead of going to the hotel, like, so if somebody wants to go get a hotel room, right? Instead of just showing up to the hotel and saying, I want a room. Well, there's none available. You went all the way out there, booked your flight all the way out there, and there's no hotels available. There's no hotel room available. Okay, so what he's saying is, why don't you call first when you place the order in? Hey, are there any rooms available? Can I get a reservation? And if there are for that day, it'll say, yes, we have a reservation here, or no, it's all booked up, sorry. And give an error, right? That's always a time-bound lock.
In this case, our resource is the balance. If you're familiar with a credit card, an authorization is exactly this. It's reserving funds for a period of time. So my end service bus saga, which to illustrate this, is going to do the authorization, as well as a timeout that if our orders aren't set as paid, we can cancel that authorization. If our orders do get set as paid, we can kind of complete the transaction. So I have everything being kicked off here by the subscription paid event that we're consuming, and then we're going to send a reconcile unpaid orders. Orders at this point is going to look at what orders are outstanding, and it's going to be sending command to authorize those amounts.
Yeah, this is all C# stuff. KTOR does this differently, and you're gonna have to kind of like roll your own a little bit of this kind of stuff. And there are some examples of how to do the saga pattern, which is using right here, the saga pattern. But so this code isn't exactly how you're gonna do it, but it'll be something similar to this.
Once it does so, we're going to get an amount authorized that we're going to consume. From there, we're going to set our orders as paid because everything's been authorized. But we're also going to set a timeout for 10 seconds, just as some random number that I decided. But that's going to be a threshold for if the orders aren't marked as paid within 10 seconds, we're going to basically do a cancellation of that authorization. So once that timeout occurs, we can send our cancel authorization to the payment service, which basically whatever internally it's doing to keep track of authorizations in our balance. And then if the orders actually are set as paid and everything.
So he's just doing the saga stuff. So this is the sagas are like, okay, so if you call somebody up and you have to do 2 reservations, like car rental and a hotel rental, and you call up the car rental place and say, yeah, we got the car, but if you call up then you call up the hotel next, it's like, no, there's no hotel. Well, you have to call the original car rental place and say, I can't make it, and cancel my reservation or cancel my car thing. That's the whole idea of a saga, a rollback saga. That's the whole idea. Okay,
work with it, then we can complete the authorization to as well update our balance. So now we're consistent with what our orders say and what the balance is. Now there's one more solution, which I think actually might be the best solution, which is not to have the issue of data consistency in the first place. Meaning that we have this orders that has a status and we have our payments on the right, which has a subscription, which has a balance. And these are what we're trying to make consistent. Just remove the need to have them in 2 different boundaries. Why exactly does the ordering boundary, that particular service, care about the status? I'll get to that separately in a second here. So let's move the status out. So what happens is now orders doesn't have the status in the ordering service, but we're taking the concept of orders and recording that as well on our payment side. So we still have our subscriptions, which has the customer ID and the balance really is accumulation of the transactions and the orders that have been paid. But now we have the concept of orders within the payment service itself, which we have the order ID, the status, and the amount. And
so he's just saying there's 2 databases here. Or 2 tables, right? You could do 2 tables as well, but you have 2 databases here. And one database is for this particular orders, and this is another one for subscriptions. And it's got its own little database inside there that he's keeping track of the status, as opposed to just this one's just keeping track of the amount. And then if this service needs to get access to the status, it'll go ask it in a message probably, right?
As well as we have transactions still. So what happens is when an order is actually placed or created, we can just simply update its database, but then be publishing an event of an order placed event that our payment service can be consuming. It then can record what the amount is, the order ID, and then at that point mark it as just unpaid.
Right. So this can be this can be responsible for the things that only the orders are responsible for, and say I updated it, and then anyone who's interested in this system will hear this update that I just updated this database with this order thing. Anything else that'll be interested in that, we'll hear about it and be subscribed to this broker, right? And then that's what he's talking about. So it'll be like some guy going over a PA, like, "Hey, I just did this," and everybody who's interested will do their task. Like if you're in a restaurant and you say order up for hamburgers, and the guy in the fry cook goes, "Oh, I got to do a hamburger." or if you're, or if there's a, some salad that has to be made, the salad guy will hear it. It's like, oh, I get to go get the salad, make the salad thing happen. That's the whole idea.
Can then look at what our balance is and immediately mark it as paid if we have funds. So we don't have to worry about necessarily about communicating back and forth on whether something's paid or unpaid. We know that immediately within the payment service. So going back to the original use case now, where
not immediately, but right after this order goes out. So right after this order goes out, however that long takes to get to process to the broker, to them. So as soon as the order goes out and who they're paying attention and this service is up enough to like listen to it, yeah, that's when it gets it. It's when the speaker goes out. It's not the order guy going direct here and doing it the exact same time. There's a delay.
We have our client that is renewing their subscription. When they make that call to renew the subscription, we hit our payment gateway, we charge their credit card, then we record that transaction. But now we don't need to communicate with the ordering service to do all this workflow. We have that data directly within our database about which orders are unpaid. We can just look at those immediately and update those within the same transaction. We can be immediately consistent and we can reduce our balance. Again, all within the same transaction. Now, if we do want to provide the ordering service with information about what's paid and unpaid, we still can create an event and publish that to the broker and then have orders pick that up and then update their local database. But at this point, the status itself of an order is owned by the payment service, not the ordering service. So why did the ordering service have an order that owned the status? And then we had to do all this communication. I think there's two reasons. The first is because we're only ever thinking about the concept of an entity, say an order, and that concept can only live in one place and it has the be all end all. But it's not. It's really about taking that concept and the data behind it that we really require in other services for rights and for consistency. The second is because we're thinking about oftentimes about queries and how we want to display data. We're often thinking about, okay, well, the ordering service owns everything about an order. It's got to be able to show that it's unpaid or that it's paid, etc. When really we can compose that data from multiple different services. And that's exactly what some of my next videos are going to be talking about, is doing UI and view composition, where you have data in multiple different services and you want to compose that into a UI or some type of response to the client. Yeah. So make sure to subscribe if you're into these topics. If you enjoy—
that's totally legit thing to know about, and go over and do like and subscribe on his channel, because you can build these applications in all kinds of different ways, from like really simple and thinking about these things ahead of time before you build your first product is pretty good. But just going in and doing a raw MVP and everything synchronous, just to see how everything you want it to be laid out, everything that's important, and then doing a 2.0, and then in the 2.0 integrating all this asynchronous stuff, getting ready to scale. Legit. That's totally a good way of doing things, by the way, because you can get locked in this planning cycle. I've worked at companies that get locked in this planning cycle, trying to do this from the start. It's like, no, you can't. You kind of have to do a scrungy, groundy, just scrappy MVP that delivers real value, right? And then once you see what's important, what's not important, what needs to be done, then build it for this scalability. All right, give me a like and subscribe. Go give him a like and subscribe, and I'll talk to you soon.